Good afternoon. I want to thank you all for staying this late. I know it is quite late, second last session at Black Hat, so thanks for that. My name is Marcos Silveira. I work at SensePost, and I'm here to talk to you today about a piece of software called Memcached, which you may or may not be familiar with. So if you're looking for a talk called Lifting the Fog, this is the talk. I just changed the title. It seemed a little more snappy to call it Cash on Delivery. So as I said, we're a company based out of South Africa. You may have heard of South Africa in recent weeks for various reasons. I'm not going to say the World Cup, but I'm going to talk about ye old Vuvuzela, which is our traditional instrument. If you need lessons on how to play this thing, Dominic White is our resident expert, so he can show you. But enough about South Africa and the Vuvuzela. Let's talk a little bit about caching and why there's a need for caching. So we find caching throughout the systems that we use on a network level, hardware level, and also into software and applications. And pretty much we're trying to remove bottlenecks when it comes to caching. So this little picture is at a gas station, and clearly that's quite an inefficient way to dispense gas, allowing one car through at a time. So we need to come up with fixes in order to remove these bottlenecks. And one of the reasons for this is that most of the data on systems that we touch remains to a degree largely static. So there may be a few writes, but the proportion of reads to write operations is heavily weighted in favor of reads. And so actually you don't need to regenerate data at every request. And if you ponder a site like Wikipedia, there's going to be a whole bunch of database calls that need to happen. But in addition to that, there's also a templating language that needs to be parsed and interpreted. And sort of the end result of all of that is that eventually a chunk of HTML is generated. So if you can just cache that chunk of HTML, then you don't have to go through all of these other expensive operations. And so caching makes sense. Wikimedia's, or the most recent stat that I could find, says that they serve about 80% of their data from Squid. So most of their data is served out of the cache. And so it's pretty basic. Don't regenerate, rather regurgitate. So Memcached then fills a very particular niche, if you like, when it comes to big systems. So mostly we find them on large-scale systems. It's a network-based, non-persistent key-value store, which is quite a mouthful. But if you consider most programming languages, well, certainly any language written after about 1972, has some notion of a dictionary or a hash map or named arrays. Basically, that allows, it's a data structure which you get to nominate a key value or a key name and associate a value with that particular key. These hash maps, these dictionaries or whatever, as I say, are quite a common feature of most scripting languages anyway. And Memcached provides that exact functionality, except it just is a remote functionality. So it gets stored on a network server somewhere on your local network. With the idea being that you can create a Memcached server that's got vast amounts of RAM, and then the Memcached saves all of that data into RAM, and so you don't have to repeat expensive database queries. You just cache all those results in another server's big chunk of RAM. Now, because it's in RAM, it never touches the disk, so it's non-persistent. If that server dies, your cache goes away. But that's fine, because the cache is not the primary store. The cache is just there to speed things up. If the server dies, the cache dies. When it comes back up again, those entries will be regenerated by the application server. And the question arises then, well, why do we care? This piece of software was written in 2003. It's 7 years old. Why are you talking about it now? And actually, for one, I haven't found a lot on this, which speaks, I think, to our community and the time lag that exists there. But more importantly, there's a distinct profile of customers who use Memcached, and that tends to be application or development houses who have large-scale applications or providers who are running large-scale applications. Memcached is not a piece of software that you find in small sites. It's used on large deployments. So there could potentially be cool stuff there. And so just as an indication of some of the customers of Memcached, as you can see, there's just some really common or well-known players there. So to give you a little bit of information about how it works, it's a key-value store within Memcached. In order to make memory access really efficient and in order to make the storage really efficient, it groups together similarly sized values. So values that have a similar size get put into these slabs, as they are called. And the slabs have different identifiers associated with them. And basically, a slab sets a maximum bound on the size of any given value. So you may have a slab that holds keys up to 32 bytes, and then a slab that holds anything from 32 to 64, and a slab that holds from 64 through to 128, and so on. And for end users, actually, they don't care. Slabs are irrelevant to them. But for us, if we're trying to get info from the Memcache, we need to know a little bit about slabs, hence this particular slide. So we need to know a bit about that. But if we actually talk about how it works under the hood, it uses this really trivial protocol. It's a text-based, an ASCII-based protocol with a tiny command set. So there's 15 commands that I count. And in fact, we don't even care about all 15 commands. We care about 3 in particular. Generally, the way that it gets deployed is through a server that sits somewhere on the local network, or it's local to the application server or the web server. And there could exist long-lived TCP connections between those two. So you save on teardown costs and three-way handshake costs. And so then it's just a web server or the application server queries the Memcached for values that it wants at a given point in time. So as I say, it really is a trivial protocol. We can, well, I want to show you just how trivial it is, and I suspect this is one of the reasons why we got some of the results that we did. So in order to run Memcached, so it's compiled and all of that, at this point, there's no config file, there's no command line options. I just run it, and it's now good to go. At this point, it's listening on all interfaces, which is an interesting default choice for a piece of network-facing software. So it's listening on all interfaces. We can connect to that using a standard Telnet client. And as I say, it's text-based. There are a number of commands that we can enter at this point. And so if we try to get something out of the cache, let's get test key. You notice there's no value there. We can't retrieve that particular key. It's because we've just started the server. It's non-persistent. The server is a blank slate. So let's write something into the cache. We set a key name. There's an expiry time as well as an optional flags. And then we specify the number of bytes that we want to write into the cache. We write 5 bytes in. They're now stored. The cache knows about it. So we can then ask the cache for that key, and we get the values, 1, 2, 3, 4, 5. Pretty simple. As I say, it's a trivial protocol. There is one last command that is kind of useful for us, and that's the stats command. So if you hit stats, the Memcache server will output a whole bunch of basic diagnostic info. And there's a number of subcommands to this that we'll get to shortly. But as you can see, it's really trivial to talk to. Now, there's something that's definitely missing from that. Think about it for a second. Okay, thinking over. Authentication, authorization, any of that cool stuff is not present within the Memcached protocol. And the reason for that is it's designed to be deployed extremely close to the web server or the application server. And so in terms of when it was originally designed for LiveJournal, they didn't need any of that stuff. Times have changed. Memcached now run off hosting providers in the cloud. And that means that they're no longer local to the environment in which uses them. And that's kind of a big change that hasn't really been followed through with the protocol. Now, in fairness, there is a binary protocol and a UDP protocol. The binary protocol in particular changes a little bit, some of those things that I said, but most clients don't use them because the libraries don't support them. So we didn't touch them for this particular piece of research. And so consider that. No username, no password. You connect to a service, you get lots of info. I don't know about you, and these were just some of the sample that I showed you. I don't know about you, but no auth sounds a little bit to me like 1998. Backstreet Boys, top of the charts, tearing things up, and blank SA passwords to be found everywhere, anonymous FTP, Oracle with default creds. And that's really what it feels like. Like it feels a little dirty to be going through and doing the same kind of stuff. But I'm lazy, and certainly I've been accused of being dirty before, so it's not beyond me at this particular point. So some of the goals that we're looking for are the following. We want to find and connect to Memcached servers. Once we connect to the Memcached server, we need to enumerate the slabs that are present, so those blocks of, or those collections of entries. And from that, we pull out the ID numbers for each slab. Once we've found an ID number for each slab, we then get to pull out the key names from each slab using particular features of the protocol. And then we get to pull out the key and its value. And so that's the really simple way to mine a Memcached server. So how do we pull out the slab ID numbers? Again, use the protocol itself. There's stats commands that will pull that for you. So here we can enter stats slabs, and you can see that we get stats on a particular slab. So there's only one slab at the moment in this Memcached server. So we get access to that. Cool. The next things that we need to get access to are the key names themselves from each slab. And for this, again, we rely on the protocol. There's features in the protocol that will let us do that. So those features are a little command called stats detail on. That enables extended collection of statistics within the server. Again, remotely, you get to enable further debug commands, which is, again, interesting. And then there's a cache dump command that allows us to specify both the slab ID and the number of keys we want to extract from the slab in question. So at this point, I've said to the server, give me 10 keys from slab 1. There was only one entry in that slab, which you saw me store. Hence, there's only one result. And here we get back the key name that we were looking for. So now we can, using these simple basic steps, extract a list of all the keys within the Memcached server, which is nifty. So as I say, there's stats detail, the stats cache dump, which I just showed you, where we supply a slab ID, a key limit, and we get back the key list. So this allows us to start pulling data from Memcached servers around the internet. And we don't actually have to go with any kind of complex hacks here. Literally, follow the protocol, you get access to the data. And so the question then becomes, well, what can you do with caches that you do find that are exposed? And there's two options in general. The one is to mine the cache, extract all the data that you can out of it. Possibly you may find interesting stuff in there. And we'll talk a little bit about that. And it's useful because, there's that SQL injection stuff, which is kind of hard. Or 1 equals 1, I always get that single quote mixed up, something about a double dash. And so this is just a lot easier for me to pull information from a given site, if you can find the cache. But the second one, which is more interesting, I think, is to talk about altering the data within the Memcached server. And there's really three options that you've got there. The one is to add new entries to the cache. The second one is to delete entries from the cache, and the third one is to overwrite entries within the cache. Now, if you think of adding entries to the cache, it doesn't really buy you too much. So you put something in someone else's Memcache, but they're not looking for it. And so whether it has an impact on them is probably negligible. If you're a privacy kind of guy, you may think of a use for, consider that this is a store somewhere on the internet on someone else's server that never touches disk. So that may have implications for someone with an interest in privacy and or hiding stuff. But I'm not going to go there. Deleting entries also isn't that interesting. If you delete an entry in the cache within this model, all it means is that the server should regenerate, the application server should regenerate the entry and store it again. Big deal. There is a flush all command, which I guess if you're looking to place a huge load on someone's application server, that may be effective. So you can clear the cache completely with one command. But I'm more interested in overwriting entries within the cache. And there's basically two things, again, that we can look at there. We can look to target the users of that content. So an application server presumably is going to extract information from the cache, serve that to the client. You get to target an entire user base. And on the other hand, you get, through a particular technique I'll show you now, you get to target the server itself through entries in the Memcached. Okay, so I'm going to first do a quick demo on mining the cache. We've got this little tool we wrote called GoDerpa. It's a Memcached miner. And what it's able to do is you tell it how many keys to pull from each slab, and it goes off and it does its thing in the background, and it'll come back and give you all the data that it could find. It writes all of the data out to disk, so you get to inspect it later on at your own pace. And then the one other feature that it's got a few features, but the one thing it'll do for you is